Today I would like to talk about rotating biological contractor, which is a biological way of treating wastewater, and it's much more eco-friendly comparing to chemical treatment of wastewater. In biochemical treatment of wastewater, actually we use microorganisms, and they can be grown in two ways. One of the way is suspended growth, while other is fixed growth, where we have forming of biofilm on discs, also known as media. This kind of the system is exactly the one which is used in RBC, and RBC actually represents the secondary treatment process, which means that partly clarified wastewater comes to the system, is in contact with microorganism, and in the end of the process, effluent is much more clarified. Every RBC has in the beginning and in the end actually clarifies, and between there is a RBC units, also known as train, and every stage has immersed discs. In the beginning of the system we remove organic matters, while after that we deal with nitrification or denitrification. Discs are made of polyethylene, PVC or polystyrene. They're put in the shaft, and during the system partly they are exposed to oxygen and air, and after that they go to the wastewater, from which they take organic part of the metabolically needed composition. Discs are immersed around 40% in wastewater with a speed 1 to 2 rpm, and we can have standard or high density in the disc depending on in which part of the process they are used. So standard are usually used in the beginning for organic removal, while high density is usually used for nitrification. Also, we have randomly packed media which have better area for updating oxygen and also to forming biofilms, and this kind of system gives good results in labs and also in pilot scales. But no matter which kind of media actually we have, the process is actually the same. Next to the disc media we have forming of anaerobic layer, after that we have forming of aerobic layer, and along the depth we have change in density, metabolic activity of biomass, and also in porosity. Except for the biofilms, we also have forming of liquid film, which helps to part of the oxygen being brought from the air to the wastewater, and this way we have better hydraulic loading. After all, we need to control thickness of the biofilm, and this can be done thanks to wastewater temperature, oxygen supply, or different loading rates for organic matters. Also, if we change the direction of the rotation or its speed, thickness can be controlled. But in one moment we need to remove part of the biomass, and that can be done thanks to shearing force. Precipitation is done, and then the sludge is removed to following basin. But no matter which kind of control we use, we also should think about scale up in systems like this, and criteria are first of all hydraulic loading, then how much RBC units we're gonna need, and what will be rotation. This is why we need good process design, and process design can start actually with first parameter, which is which diameter we actually need from media, then which rotation speed we should use, and thanks to that speed what would be actually loading of biomass. Having this kind of data, we go further and start to think about mass transfer coefficient, how much oxygen we're going to have in the system, and based on this data, how many RBC units we need actually in our systems. This data can be changed in calculation, and by changing also rotational speed, we can make the best possible way for removal of BOD, or biological oxygen demand, and after that we of course need to think about cost. What are fixed costs, what are costs we can have impact, and how to make the system work. As many other systems, there is a lot of pros in this kind of system. Short contact time, short rotation time. We can deal with a wide range of flow actually, which can be treated in this kind of system. Also, why this system is very good is the fact that biomass can be easily removed. There is no a lot of sludge, and thanks to it we don't actually need a lot of power, so this makes this kind of system eco-friendly and less demand than some others. Also, what is very important is that this kind of system doesn't demand a lot of monitoring. They require a low skill, because controlling is very basic, very easygoing, and there is no a lot of parameters which should be monitored. Of course, as any other system, also has contras. First of all, a possibility of freezing, and that's why we need to think about better infrastructure for the system, and also mechanical parts like shafts can be broken down, so one should pay more attention about these kind of things. In the end, if we want to use precise strain, we should think about contamination in the system, what should be composition of effluent which is used, and also how our strain is going to interact with other microorganisms in biofilm.